What is overfitting in data science? Imagine you spend hours memorizing every answer to a practice test, but when the real exam comes, you struggle. That's similar to what happens when a data model overfits. It learns the training data so well that it captures noise and random fluctuations, not just the true patterns. This means the model performs perfectly on the data it was trained on but poorly on new, unseen data. Think of a model as a student preparing for a test. If the student memorizes answers to specific questions without understanding the concepts, they might ace practice tests but fail on the actual exam with different questions. Overfitting is like that. The model becomes too tailored to the training data, including outliers and errors, which makes it less flexible for real-world data. Overfitting often happens when a model is too complex compared to the amount of data available. For example, a model with many parameters or one that tries to fit every data point exactly, including noise, can overfit. This complexity causes the model to mistake random noise for meaningful information. To see if a model is overfitting, data scientists compare its performance on training data versus new data. If it does very well on training but poorly on test data, overfitting is likely. To prevent this, they split data into training and testing sets to check how well the model generalizes. Simplifying the model by reducing parameters or choosing less complex algorithms also helps. Increasing the amount of training data gives the model more examples to learn from, making it less likely to memorize noise. Regularization methods add penalties to complex models, discouraging overfitting. Early stopping during training halts the process before the model starts to memorize noise. Techniques like dropout in neural networks randomly turn off parts of the network during training, making the model less reliant on specific features. For those building a career in data science without a traditional degree, understanding overfitting is key. It shows you know how to create models that work well not just on known data but also in real-world situations. Recognizing and fixing overfitting demonstrates your ability to develop reliable, practical solutions. This skill is highly valued by employers because it means your models will perform consistently when applied outside the training environment. So, mastering how to spot and prevent overfitting can really set you apart in the competitive world of tech careers.